1. What is machine learning? Explain with example. Definition. Machine learning is a modern innovation that has enhanced many industrial and professional processes as well as our daily lives. It's a subset of artificial intelligence, AI, which focuses on using statistical techniques to build intelligent computer systems to learn from available databases. Examples of how machine learning is being used. 1. Image recognition. Image recognition is a well-known and widespread example of machine learning in the real world. It can identify an object as a digital image, based on the intensity of the pixels in black and white images or color images. Real-world examples of image recognition. Filled circle label an X-ray as cancerous. Or not. Filled circle assign a name to a photographed face, aka tagging. On social media, filled circle recognize handwriting by segmenting a single letter into smaller images. Machine learning is also frequently used for facial recognition within an image. Using a database of people, the system can identify commonalities and match them to faces. This is often used in law enforcement. 2. Explain types of machine learning. Answer. Machine learning is a subset of AI, which enables the machine to automatically learn from data, improve performance from past experiences, and make predictions. These milliliter algorithms help to solve different business problems like regression, classification, forecasting, clustering, and associations, etc. Based on the methods and way of learning, machine learning is divided into mainly 4 types, which are 1. Supervised machine learning. 2. Unsupervised machine learning. 3. Semi-supervised machine learning. 4. Reinforcement learning. 1. Supervised machine learning. As its name suggests, supervised machine learning is based on supervision. It means in the supervised learning technique, we train the machines using the labeled dataset, and based on the training, the machine predicts the output. Categories of supervised machine learning. Supervised machine learning can be classified into 2 types of problems, which are given below. O. Classification. O. Regression. A. Classification. Classification algorithms are used to solve the classification problems in which the output variable is categorical, such as yes or no, male or female, red or blue, etc. The classification algorithms predict the categories present in the dataset. Some real-world examples of classification algorithms are spam detection, email filtering, etc. Some popular classification algorithms are given below. O. Random forest algorithm. O. Decision tree algorithm. O. Logistic regression algorithm. O. Support vector machine algorithm. B. Regression algorithms are used to solve regression problems in which there is a linear relationship between input and output variables. These are used to predict continuous output variables, such as market trends, weather prediction, etc. Advantages and disadvantages of supervised learning. Advantages. O. Since supervised learning work with the labeled datasets, so these algorithms are helpful in predicting the output on the basis of prior experience. Disadvantages. O. These algorithms are not able to solve complex tasks. O. It may predict the wrong output if the test data is different from the training data. O. It requires lots of computational time to train the algorithm. Applications of supervised learning. Some common applications of supervised learning are given below. O. Image segmentation. Supervised learning algorithms are used in image segmentation. In this process, image classification is performed on different image data with predefined labels. O. Medical diagnosis. Supervised algorithms are also used in the medical field for diagnosis purposes. It is done by using medical images and past labeled data with labels for disease conditions. With such a process, the machine can identify a disease for the new patients. Fraud detection. Supervised learning classification algorithms are used for identifying fraud transactions, fraud customers, etc. It is done by using historic data to identify the patterns that can lead to possible fraud. Spam detection. In spam detection and filtering, classification algorithms are used. These algorithms classify an email as spam or not spam. The spam emails are sent to the spam folder. Speech recognition. Supervised learning algorithms are also used in speech recognition. The algorithm is trained with voice data, and various 2. Unsupervised machine learning. Unsupervised learning is different from the supervised learning technique. As its name suggests, there is no need for supervision. It means, in unsupervised machine learning, the machine is trained using the unlabeled dataset, and the machine predicts the output without any supervision. In unsupervised learning, the models are trained with the data that is neither classified nor labeled, and the model acts on that data without any supervision. Categories of unsupervised machine learning. Unsupervised learning can be further classified into 2 types, which are given below. Clustering. Association 1. Clustering. The clustering technique is used when we want to find the inherent groups from the data. It is a way to group the objects into a cluster such that the objects with the most similarities remain in one group and have fewer or no similarities with the objects of other groups. An example of the clustering algorithm is grouping the customers by their purchasing behavior. Some of the popular clustering algorithms are given below. K-means clustering algorithm, O-mean shift algorithm, ODBSCAN algorithm, O-principal component analysis, O-independent component analysis. 2. Association. Association rule learning is an unsupervised learning technique, which finds interesting relations among variables within a large dataset. The main aim of this learning algorithm is to find the dependency of one data item on another data item and map those variables accordingly so that it can generate maximum profit. This algorithm is mainly applied in market basket analysis, web usage mining, continuous production, etc. Some popular algorithms of association rule learning are a priori algorithm, ACLA, a growth algorithm. Advantages and disadvantages of unsupervised learning algorithm. Advantages. These algorithms can be used for complicated tasks compared to the supervised ones because these algorithms work on the unlabeled dataset. Unsupervised algorithms are preferable for various tasks as getting the unlabeled dataset is easier as compared to the labeled dataset. Disadvantages. The output of an unsupervised algorithm can be less accurate as the dataset is not labeled, and algorithms are not trained with the exact output in prior. Working with unsupervised learning is more difficult as it works with the unlabeled dataset that does not map with the output. Applications of unsupervised learning. Network analysis. Unsupervised learning is used for identifying plagiarism and copyright in document network analysis of text data for scholarly articles. Recommendation systems. Recommendation systems widely use unsupervised learning techniques for building recommendation applications for different web applications and e-commerce websites. Anomaly detection. Anomaly detection is a popular application of unsupervised learning, which can identify unusual data points within the dataset. It is used to discover fraudulent transactions. Singular value decomposition. Singular value decomposition or SVD is used to extract particular information from the database. For example, extracting Information of each user located at a particular location. 3. Explain mini-batch gradient descent. Answer. In batch gradient descent, all the training data is taken into consideration to take a single step. We take the average of the gradients of all the training examples and then use that mean gradient to update our parameters. So that's just one step of gradient descent in one epoch. Neither we use all the dataset all at once nor we use the single example at a time. We use a batch of a fixed former variants we saw. So, after creating the mini batches of fixed size, we do the following steps in one epoch. 1. Pick a mini batch. 2. Feed it to neural network. 3. Calculate the mean gradient of the mini batch. 4. Use the mean gradient we calculated in step 3 to update the weights. 5. Repeat steps 1 to 4 for the mini batches we created just like SGD. The average cost over the epochs in mini batch gradient descent fluctuates because we are averaging a small number of examples at a time. So, when we are using the mini batch gradient descent, we are updating our parameters frequently. As well as we can use vectorized implementation for faster computations. 4. Explain the term training, validating, and testing with example. Filled circle training data. This type of data builds up the machine learning algorithm. The data scientist feeds the algorithm input data, which corresponds to an expected output. The model evaluates the data repeatedly to learn more about the data's behavior and then adjusts itself to serve its intended purpose. Filled circle validation data. During training, validation data infuses new data into the model that it hasn't evaluated before. Validation data provides the first test against unseen data, allowing data scientists to evaluate how well the model makes predictions based on the new data. Not all data scientists use validation data, but it can provide some helpful information to optimize hyperparameters, which influence how the model assesses data. Filled circle test data. After the model is built, testing data once again validates that it can make accurate predictions. If training and validation data include labels to monitor performance metrics of the model, the testing data should be unlabeled. Test data provides a final, real-world check of an unseen dataset to confirm that the milliliter algorithm was trained effectively. For example, let's say an milliliter algorithm is supposed to analyze a picture of a vertebrate and provide its scientific classification. The training dataset would include lots of pictures of mammals, but not all pictures of all mammals, let alone all pictures of all vertebrates. So, when the validation data provides a picture of a squirrel, an animal the model hasn't seen before, the data scientist can assess how well the algorithm performs in that task. This is a check against an entirely different dataset than the one it was trained on.